How many of you know about Zensar? Only few. I'm sad. Okay, so Zensar is there for quite a long time, and it's almost 100 years old. We are a part of RPG group. How many are East Bengal fan here? No East Bengal. Bangalore FC. Okay, good. So people who are, it's a conglomerate. RPG group is a conglomerate, and I head the AI practices for Zensar, and we have a labs called Zen Labs. In Zen Labs, we have two verticals that it's under me. One is AI/ML, another is a blockchain. This is the team that has worked, I would say, for almost 6 months to develop the solution. Feli is sitting there. Mahesh is here. Other people could not attend, but they are in different parts of India. So, as I was talking about a little about Zen Labs, that our focus is start with a research and end up with a product or a solution that helps our customers. And focus area, as you can see, that research, patents, and you can see over there around 152 patents right now, including 2 in generative AI, as well as large language models. So we have a couple of GPUs. We are not as big as Google, Microsoft, or others, but we are building our own small language models, I would say. And yes, we have best data scientist with us, and that's why you see this paper. We have presented in a couple of conferences. About myself, I hold 14 patents in AI, and around 3 of them are in generative AI. So I started working when I was in Accenture in generative AI, and we got patents from there itself. I have around 24 research papers in AI/ML. He had around 5, Feli had around 6, she has around 3 best paper award, and Mahesh has around 2 best paper award. I have 5 best paper awards. These are all from international conferences. As you can see that IEEE Springer, and this labs is not just a lab. We are a DSIR certified lab, so it's a government recognized lab. I'll move on. How are we able to do this? In labs we are around 20 people. My overall team size is around 250 people. How are we able to do it? As you see that labs is there, but GenAI or AI, ML doesn't work in silos. You can't just take a model and think that it will work in the production system. So what we do is we have formed a GenAI ecosystem. We are a GenAI ecosystem partner. So what we do is we alliance with startups, academia. We have joint go-to-market solution with Google, Microsoft, AWS. We have a couple of solutions that was presented in AWS Summit. Please go to our website and check that out. These are our offerings, and you can also visit our website. We build every AI solution responsibly. We audit the AI solution. We have a GenAI auditor, which is patented. Now coming to the actual, what did we build? The initial thought that we have is one of the most difficult data set is time series. How many of you have worked on time series? Fantastic. Have you ever tried chunking the time series and then trying to predict? Will it work? Yes, no? I see one nodding head. No, it's not possible. With this methodology, it is possible. You can chunk, and I'm sure you guys all know our retrieval augmented generation, RAG. So RAG, one of the steps is chunking. We started with chunking, and as you guys know, it did not work. Time series doesn't work on chunking. But that was the challenge we took up. We ensured the time series works chunking, and we are able to extract. How many of you know embeddings? Fantastic. I'll come to that. So IEX dataset is readily available. So it's Indian Energy Exchange data. Algorithmic trading, like a lot of traders are there. So it's similar to that. The traders use this to buy, sell energy. And I think Mahesh will talk about how the data looks like. And also, what I would move to the next slide is, as I was talking about, when we were doing this research, what we found out that first of all, the problem with this, the IEX, people who are using this IEX data, is that they have to see a dashboard. In the sense, either a business BI dashboard, they have to actually see a BI dashboard to understand. They can't ask questions to the dashboard and get insights. Like if I need to know what happened exactly to my, I would say, the trading line at a certain point of time, I actually have to go inside, identify on those. Now you can chat with your dashboard. You can simply chat. That's not it. That's nothing great about it. How many of you use only large language models and generative AI for chatting? I think everybody uses, right? Everybody uses for chatting. How many of you use for taking actions? Great. So in reinforcement learning, there is a concept called agents. And that concept has come into the recent GenAI agents, which takes certain actions. And here I'll talk about how we are taking actions. This model was built by an agent. So we prompted the agent to build the model. It built it by itself. I'm not taking anybody's job here. So that's a disclaimer. But it was able to build it by itself. Data set.
Hello. Hope I'm audible to everyone. So for training our forecasting model, we have extracted the data from Indian Energy Exchange website. Okay. So here you can see here like Indian map where total 14 zones are there. These are trading zones. Those are categorized by the IEX. Like total there are 14 with a color code with the different colors, right? So yeah. So the data is like it's a energy price for every 15 minutes, which we used to get. Okay. So we have downloaded previous 2 years data to train our model. Whatever the pre-processing steps were there to clean the data and other steps, we did that, and we fed the data into our model. So to train the model for forecasting the this one, the energy prices for the next 7-day horizon. Yeah, next slide, please. Yeah. This is the snippet of our the chartboard system. Okay, so here we have integrated 2 agents. One agent takes care of the predictive modeling of the energy prices, and the second one is generative AI enabled, like that will give us the interactive reports, graphs, and question and answer sort of thing. So in the left hand side, you can see the UI. So here this is basically a predictive modeling UI. So here whenever like a user comes and he asks for a particular day's forecasting, he has to choose the number of days, and then there is a provision to choose the start date as well as the end date. Okay, so after selecting the start date and end date, just he has to click predict button. So he'll be able to visualize the graph as well as the forecasting data for the next 7 days or whatever the time frame he will select. Okay, this is about the price prediction app. This one, the right hand side, this is the main point of focus of our research. Okay, so here we used a GenAI enabled kind of a chartboard here. So here user can interact with the forecasted data as well as the actual data. He can ask questions related to statistical reports like give me the mean, max, average, and when should I buy the stock, or when should I buy the energy. That kind of questions he can ask. Right, and apart from asking a question, so he can also ask to generate the reports, like give me the report of that particular day's trading or whatever. Right, so and even he can ask Gen AI to give the graphs as well about the data. Yeah, over to you.
Right, so as Mahesh was explaining, there are 2 agents, and this is the architecture that it works. So here the user interacts with whatever Mahesh showed, the application, and we tried not only ChatGPT v4 based, which worked really well, but we tried with Minstrel, we tried with Llama, we tried with Falcon, starting from 7 billion parameters to 13 million parameters. We tried everything, but what really worked well is our GPT v4 model. And as you see, the first agent, it only does prediction and forecasting. Now, the good part about that agent is that has been prompted to train that data. So what we were doing is, there's a concept in software development called competitive development, where a person or I will say developer competes with another developer to come up with the best. Here our developer competed with the chat GPT or GPT rather to go ahead and come up with the best model, and definitely GPT cracked it. It was much better, and I will show you the graphs after this. Now the first agent interacts or connects to the second agent using a database. Once it's trained, it dumps the data here. The second agent goes and interacts with the data. They communicate to each other. So they understand each other language. There is an API that has been built at the back end, which is like a standard operating procedure for these two agents. Now, the good part about the second agent, you see all these tools. How will the agent interact? The agent will interact through tools. The agent calls the tools. The tools can even interact with any kind of API and take actions. So that's what it is doing. It's generating report. It's recommending when to buy and sell. It's responding to the user query. Now, this agent has been scaled. Because let's say I'm deploying this for 10,000 people. It cannot go ahead and hit only one agent. It also has its own memory. So it acts like that. So everything has been taken into consideration. Now, one thing that I wanted to emphasize, and I'll just go back to this slide once again. Just give me 1 minute. Yeah, so this is the in-depth, and before, I think I'll just go back once. So you see this GPT v4, and then you see this one. Just hold on to your thoughts for this one. I will take you to this slide first. We extract the data. I was talking about creating time-delayed embedding. And here is what time-delayed embedding means. I was talking that it cannot, in time series, you cannot chunk the data. But if you're using time-delayed embedding, which is actually taken from a Taken's theorem. So Taken's theorem, if you go to, I'm not getting into Taken's theorem, but if you go to Taken's theorem and go to time-delayed embedding, it actually chunks the data in a way, and you can use that chunk with, I will say, an hyperparameter that we have used to go ahead and maintain the relationship. So that's, I would say, time-delayed embedding. And this is how the data comes. The data time-delayed embedding gets chunked. It's a basic RAG at this point of time. Goes to the embedding model, gets the embedding, gets indexed. Yes, it is on Azure if you're able to recognize it. It's on Azure. It uses cognitive search as one of its vector database. We have tried with other vector databases as well. It has a multimodal capability, and what worked better in Azure was because Azure, the cognitive search, we call it Azure search, is very strong when it comes to having the vector database capability. The other equivalent one that worked pretty well for us was not ChromaDB, not Pinecone, but it was something called a Quadrant DB. I don't know, anybody has worked with Quadrant? Fantastic. So that worked pretty well because we were embedding even images and text as well as the time series together. So now once we create that, and that's the machine learning model. Now one thing you guys will try to understand that we create one embedding, rather one group of embeddings, and we use it to train the model. The model has been trained using these embeddings, as well as we are using it to vector database, and the whole heart of our solution is this embedding. It worked fabulously when we were able to take that, ask questions, do multiple things. One question to you guys: why do I need to use large language models, or let's say GenAI? I can even develop multiple AI models and do the same job. Why do we use this generative AI large language models? Keep the chat piece aside. Why do we use it? Any reasons that you guys can think about? Okay, so yeah. No, it's not. No, so let me come to that. See, what we use it for, because this large language models and Gen AI has the power of doing multiple tasks. And you saw that in the previous slide. We can go ahead and build multiple AI models, store them, maintain them, but for Gen AI, that's the capability or facility that you use one model, it knows. It acts like a god, I would say. So here, the user's prompts, in order to avoid, I think the prompts which are, I would say, repetitive prompts or repetitive queries, we have a cache. We have definitely an API manager there. The first it goes to cache, it searches, are there similar prompts available? It directly gives the answer. We save token counts there. There is an orchestrator. We all know about LangChain. It's not there. It's not mentioned there. It goes to embedding. It gets the embedding. It goes ahead, goes to cognitive search. It matches the embedding, gets the top K. Everything's same, exact same. Here comes the agent part. The agent or two agents, it start doing the tasks. Tomorrow, you tell it to go ahead and play a game. It will play a game. I mean, it's not this one, because it has a guardrail around it. You cannot simply ask anything to the agent to do anything. So we have also got a guardrail. Now what it does, recommendation, prediction, forecasting, everything together, because of this embedding, as well as we have, I will say, we have done a couple of other changes to the multi-agent model, and it knows it. Now it goes back, saves the data to the cache, and gives the answer. Now that is the recommendation. Now here is I was talking about the tasks. It actually can go ahead and use a downstream application and help. Let's say you want a downstream application to act as a firewall based on prompt. That also it can do. So that's the power of agents over here. The results are stored. Let's say a task has been done successfully. If there is a failure, it retries. I think whoever has used ChatGPT, there is an option that, or rather not option, it does it. If it fails a task, it retries and retries till it's successful, or else it will throw an error that it was not able to do it. And then when it goes back to the human. So it comes back to the user, and these users, one of the things that we have not mentioned are the data cannot be shared, in the sense, if my data, I am only allowed to interact and get answer from my data. If it's Mahesh data, Mahesh is only allowed to get the answer. If it's Feli's data, then Feli is only allowed to get the answer. And that is called, there is a concept called tenancy. So we have also enabled a tenancy in that. And this is a product that right now around 5 of our customers are using it, parts of it, not the entire thing. So this is on the right side, whatever you see, training and validation. This is an exact curve. It's not overfitting. This is the exact curve that you want to get if you are training a deep learning model. Not anything, the validation should not go up. That should not happen. So this is what you need to get, and that is what has been done by the GPT model. That is what it has trained. This is how the forecasting looks like, and this is the, I'll say, the actual trend, and it's very difficult to see because it's such a close way it has mimicked. It's amazing how it has done it by itself. There were multiple other techniques that we have used, probably offline we can talk about it. So to conclude, why did we even do it? Because we were lazy, we didn't want to train our model. No, not like that. We wanted to compete. We wanted to see how the embeddings work. Can I go ahead and ensure that the embeddings for a time series works, as well as we wanted the reports to get generated, agents to take actions, agents to talk to each other, and not go sentinel. That's something that we need to be aware of it. We had guardrails, we created a product. So that's, I would conclude, I am okay to take a question. You can go to zensar.com, you will find our products that I showed and our solutions and about our company.